Okay, so this video is going to cover the difference between the absolute and the apparent magnitude of stars for the astrophysics unit. So the apparent magnitude scale is kind of goofy. So it starts with 6, which is defined as a barely visible star. So this would be the dimmest star you could see in the night sky. You might not be able to see this in a city, but in the countryside or something. So it's the dimmest star you could possibly see. On the other end of the spectrum, is plus a star which would have an apparent magnitude of +1, which would be 100 times brighter than the dimmest star. Okay, so 6 is a dim star, +1 is 100 times brighter than that star. And every time we go up one increment in magnitude, the luminosity of the star increases by 2.512 as a factor. So that's, and I forgot to mention, apparent magnitude we represent with a lowercase m. Absolute magnitude, on the other hand, we represent with an uppercase M. And so absolute magnitude takes into account that the stars are different brightnesses because they're all different distances from Earth. So if we know the distance of the star, then we can compare the stars directly using this measurement of absolute magnitude. So basically what this measurement does is it brings all the stars to 10 parsecs from Earth, and then we measure their apparent magnitude at that point. So, and this means that the majority of the stars will actually have a smaller numerical value for absolute magnitude than for apparent magnitude, because when you bring the stars very, very close to Earth, they'll be very negative, or even smaller than 0. When we convert between absolute and apparent magnitude, we can use this equation, which is found in your data book. Apparent magnitude minus absolute magnitude is equal to 5 times the log of the distance over 10. If we wanted to use the apparent magnitude and the absolute magnitude to find the distance to the star, we can rearrange this equation by taking, 5 minus m, and minus m equals 5 log d minus 5 log 10. 5 log 10 is just 5. So m minus capital M plus 5 equals 5 log d. I'll divide both sides by 5. Equals the log of d. If I take both sides over 10, so 10 to the m minus capital M plus 5 divided by 5 equals d. So if I wanted to use this equation and I know the apparent and the absolute magnitude, I can use this equation to also find distance, d. If I wanted to compare the absolute or apparent magnitudes of stars, I could use these other equations that we can find in the data book. So the important thing to remember is when using these equations that we can compare we can compare the apparent magnitudes using brightness, because brightness, if you'll remember, is equal to luminosity over 4 pi d squared. So brightness takes into account the distances they're apart, so we can compare apparent magnitudes using this. If we wanted to compare luminosities, we have to use absolute magnitudes, because luminosity doesn't take into account the distance. Okay, so that's it.